This will be the last discussion of this topic. It is the speed versus time graph and the distance versus time graph. I hope you will learn and obtain the deeper understanding of the motion. I will start our discussion using the car, which has an initial speed 5 meter per second and accelerates 1 meter per second square, so that the speed after 1 second is 6 meter per second, and after 2 seconds will be 7 meter per second, 8 meter per second, 9 meter per second, and so on. Therefore, the distance traveled by this car will be different in every second. From t is equal to 0 until 1 second, it will travel 5.5 as you already saw earlier. And then from 1 second to 2 seconds, it will travel 6.5 meter. And from 2 to 3, it will travel 7.5 meter, and then from 3 to 4 seconds it will travel 8.5 meter. So from the beginning until 2 seconds, it will travel 12 meters, and the distance from the beginning until 3 seconds will be 19.5 meter. And also the distance travel from the beginning until 4 seconds will be 28 meters. Let's first do the speed versus time graph for this car. As you see here, the initial speed of the car is 5 meter per second, and it's accelerated 1 meter per second square, meaning that every second the speed will increase 1 meter per second. Now you can tell that at t is equal to 1, the speed will be 6, and at 2 seconds the speed will be 7, and so on. Finally, if we put this number into the graphs, you will get this point. So at t is equal to 0, the speed is 5, and at t is equal to 1, the speed here is 6, and then the speed is 7, and 8 and 9. And if you connect these points, you will get a straight line that has a slope. Now, what can we get or calculate from the graph? First, we can calculate the acceleration. Let me show you. So let us now choose 2 points here. For example, if I choose the initial point and the last one here, and if we calculate the slope or gradient of this straight line using these 2 points, in this case, the delta V, and here we have delta T. So if we divide the increase of the speed and the time here, we will get the acceleration. So for example, in this case, if we calculate, the delta V will be 9 minus 5, so this is 5 and then this is 9, divide by 4 seconds, and you get 1 meter per second square. So that's the first thing we can calculate from the speed versus time graph. Next, we will draw the distance versus time graph. As you already knew that the distance of the car is different in every second. So this is the distance in every second. Let us now put the distance in the graph. So from 0 to 1 second, the car moves 5.5. This is the distance. And then from 0 to 2 seconds, the car moves 12 seconds. And then from 0 to 3 seconds here, the car moves 19.5 meter. And finally, from here to here, the car moved 28 meters. So if we connect this point from the beginning, we will get what is called parabolic curve. So the distance versus time graph of the motion with constant acceleration will be different from the distance versus time graph of the motion with constant velocity. Here I show you again the car, which moves at constant velocity 5 meters per second. As you already understand that every second the distance traveled by this car is the same. It's 5 meters. So if you connect the distance here 5, and then at t is equal to 210, and then at 3 seconds 15, and then at 4 seconds 20, you will get a straight line instead of parabolic curve. Let us now see the second thing that we can calculate from the speed versus time graph. Yes, that's the distance of the object. Previously, in the motion with constant velocity, you got the idea that the area under the speed versus time is the distance traveled by the object. The same thing applies here. If we calculate the area under the speed versus time graph of the motion, you will get the distance traveled by the object too. For example, if we calculate the area here, so that's from 0 to 1 second, and you get this is 5 and 6 and 1, so that you get 5 plus 6 times 1 divided by 2, and that's 5.5. Now if we calculate the area from 0 until 2, let's draw this. This is 5, and then that's 7. This is 2, so the area will be 5 plus 7 times 2 divided by 2. You will get 12 meters. And next, if you calculate the area from 0 to 3, this is 5, and then this is 8, so you get 5 plus 8 times 3 divided by 2, so that you get 19.5. That's also the same number here. So now you get the idea that we can calculate the distance, although this is the speed versus time graph of the motion with constant acceleration. Therefore, in general, if we have a speed versus time graph for the motion with constant acceleration, and the initial speed here is v0, and after t second the speed becomes v, and here the area under the speed versus time graph is the distance. So if you calculate the value of the distance, it will be v0 plus v times t divided by 2, or the same number that we have before as we calculate the distance for motion with constant acceleration.